So now it is question number 13, which is following characteristics pertain to the sand filters used in water industry. Filtration rate is 1 to 4 meter cube per meter square per day. Typical duration of operation in one run is 24 to 72 hours. Operation cost is low. Which of the following characteristics are correct? So see, they are saying sand filters. If there is written anything something like sand filters, they are talking about slow sand filters. So filtration rate of any slow sand filter is approximately, it is around 100 to 200 liters per hour per meter square, which is in the range of given option, that is this much. Now typical duration of operation in one run is 24 hours to 72 hours. After that it needs cleaning. This is the meaning of second option. The frequency of cleaning of slow sand filter is approximately 1 to 3 months. Hence the typical duration of operation, the statement 2 is not correct. And operation cost is low in slow sand filters as it works due to gravity, works on the basis of gravity, and because of this third option is correct. So only option 1 and 3 are correct and answer will be option D. Now let's move to next question. The disinfection efficiency of chlorine in water treatment is not dependent of pH value, is increased by increased pH value, remains constant at all pH values, is reduced by increased pH values. So see, chlorination they are talking, right? Disinfection by chlorination. Now chlorination is the most effective. Chlorination is most effective at certain pH range. If pH range is between some values, then chlorination process is mostly effective. Increasing or decreasing pH, if we increase or we decrease the pH, it reduces the efficiency of chlorination. At pH, as I have already discussed this also, at pH less than 5, chlorine doesn't react with water and chlorine remains as free chlorine, not reacting. Free chlorine, right? Now, so to react chlorine, water should maintain a pH that is slightly below pH, slightly below 7, because HOCl at slightly below 7, HOCl is predominant. HOCl is predominant and HOCl is also 80% more effective, 80% more effective than OCl minus. Okay, so if pH is slightly less than 7, first of all pH should not be less than 5 because chlorine will not react. Now pH should be then greater than 5, but it should be, if possible, less than 7, below 7. That reacts perfectly in terms of disinfection. So if I write the reaction that HOCl, see this HOCl will break into hydrogen plus OCl minus when pH of water is greater than 8, and if pH is less than 7, this hydrogen plus OCl minus will recreate HOCl. Okay, and we know that HOCl is 80% more effective. So HOCl is unstable because it is getting disintegrated in hydrogen and OCl minus. So HOCl is unstable at higher pH and breaks down the reaction just like this, and it reduces efficiency. Now, so the option 1 is not dependent on pH value. That is absolutely wrong. Is increased by increased pH. Disinfection efficiency, no, not at all. Remains constant, not this. Is reduced by increased pH value, yes, it is the thing. Now, coagulation flocculation with alum is performed. Flocculation is performed. They are asking the schedule of performing coagulation and flocculation, before or after which process. So immediately before chlorination, immediately after chlorination, after rapid sand filtration, and before rapid sand filtration. So for that we should know that coagulation or flocculation is done before filtration, right? It is done before filtration, and filtration can be either by slow sand or rapid sand filters. Filtration can be done by slow or rapid, anything which is suitable. And the removal of chemical solids is easier than removing turbidity solids from surface water, and therefore higher filtration rates can be used, and this allows the use of smaller filters which reduce the treatment plant size and treatment capital cost. So we can say that if we are using filter before coagulation, it will just increase the load on filter. Load will be increased because turbidity is also not removed, so filters will work for less time because there is greater load on filters. So coagulation flocculation should be done before filtering, right? Immediately before chlorination, no, because after filtration will itself remove these things, but it will create more load. So if we add it before filtration, then it will work perfect. Next is design parameters for rapid mixing unit are. See, rapid mixing unit, what is rapid mixing unit? And they are saying some terms like velocity gradient, viscosity, velocity gradient, volume of mixing basin, detention time. So see, first of all, mixing is done in any mixing basin, or we can say mechanical mixer. Right, and mechanical mixer is also known as rapid mixing unit. This is nothing but mechanical mixer or mixing basin or rapid mixing unit, everything is same. Intensity of mixing depends on temporal mean velocity gradient. So this mean velocity gradient, it is denoted as G, is equal to under root P upon mu V, where mu is dynamic viscosity, V is the volume of tank in meter cube, P is the power, P is power in watts, G value is in second inverse, because G is what? It is the velocity gradient and unit is second inverse. So if we see the option velocity gradient and volume, design parameters of rapid mixing units are velocity gradient and volume of mixing, viscosity and velocity gradient. See, velocity gradient is there, okay. Volume of mixing is also there, okay. Viscosity and velocity gradient, yep, it is also there. Viscosity, velocity gradient, volume of the mixing basin. Now In this option, all three are collected, right? Detention time, no, this is not needed. Viscosity, okay. So option D is not suitable for us, right? Option A and option B are good, but not they are not covering all the things which are the design parameters. Power is not a design parameter, it is supplied by the operator, so it does not come in design parameters. The design parameter only is because of viscosity, velocity gradient and volume of the mixing tank. So option C is the correct option. Now if we see question number 17, pathogens are usually removed by disinfection, and disinfection is done by chlorination. Option D. Among the following disinfectants of wastewater, the one that is most commonly used is chlorine, right? Chlorine dioxide, no. Ozone, no. UV radiation, no. Ozone and UV radiation can never be used in India in current situations. Right now, if we are more economically stable, we can further increase the technology and use these things, but right now it is not that suitable for domestic use, approachable as well. So chlorine is the correct option. 19. The absorbent most commonly used in water and waste treatment is. So what is absorbent? First of all, absorbent. And what is absorption? Why do we need absorption, right? Absorbent is something which absorbs, right? So absorption is why is absorption needed in water treatment? So absorption is nothing but it is a natural process by which molecules of any dissolved compound, water when it is turbid, there are dissolved compounds, we can see that, but there are some dissolved compounds that we can't even see, and those are not good for any drinkable water. So if these molecules are present in dissolved form in the water, then absorption, any absorbent, or that means absorbing agent, if we put absorbing chemical, if we put in water, what does it do? It absorbs the dissolved compounds, and it sticks all the dissolved compounds stick to the surface of the absorbent. And the best absorbent, that is, here we all have, especially girls, they know activated carbon. Everyone knows what is activated carbon right now. So activated carbon granules are the best absorbent. They adhere all the molecules of dissolved compounds. So option B is the correct option. Next is flocculation is a process that removes the algae from stabilized pond effluent that promotes to aggregation of small particles into larger particles to enhance their removal by gravity, that mixes the coagulant in water. None of these. So we can say directly by seeing option B is correct. Flocculation is nothing but aggregation of small particles into larger particles so that it can be settled out. So this is the question.